Is it possible to make a perfect square with what you've learned so far in Euclid's Elements? The answer is yes. Okay? Now, do you remember Euclid's proposition number 1, where he took two circles, one here, he formed a perfect equilateral triangle? Well, if you form two perfect equilateral triangles like this, one here and one here, you'll notice that once you remove this line here, you have a basic square. All four of these sides here, 1, 2, 3, and 4, are equal. And that's because, for the most part, all radii of a circle are equal. And that's what you've done here. You've drawn two equilateral triangles based on the fact that all radii of a circle are equal. But this is a funky looking square. You say, well, I don't want my square to look like that. And you're absolutely right, because there's one other thing about squares that you really ought to know. Squares have equal angles as well as equal length on the sides, okay? In other words, every side of the square is equal in length, and every angle is the same measurement, okay? In this case, they're not. So how do you do that? Well, we'll flip it over here. We make a circle, alright? And we use center A here to make the circle. And what we're going to do is we're going to draw a radius from center A to point D, which is the outermost edge of that circle. And of course, we're going to draw a line from centermost A to outermost point B, which is from the center of circle A to its outermost edge, which is B. And now you have two lines that are equal in length. Why? Because all radii of a circle are equal in measurement. Alright? Once again, you're going to take your little compass and you're going to draw a circle from centermost point B to outermost point A, and you're going to do the same thing with C. So BA equals BC, because all radii of a circle are equal in measurement. Alright? So now you got three sides. Now what are you going to do next? Well, you're going to flip this around like this, and you're going to make yet another circle from point A. Well, you're going to use center D, outermost point A. You're going to curve it up. You're going to put a point C. Okay? So now you're going to draw DC, and DC and DA are equal in length because all radii of a circle are equal. And each one of these lengths are going to be equal because all radii of a circle are equal. Now, I know there were three different circles involved, but those circles were exactly the same size. So there you have it. Your perfect square, because all radii of a circle are equal. Alright, now how am I drawing all this? Now, that's been a really big question, and I'm going to give you the answer to that in about 30 seconds. Bear with me. Hang on just a second here. Aha! This is a geometry kit, as you can plainly see here. Now, I'm going to pull out two tools. When Euclid wrote all this, he only wanted you to use two tools. This is the first one right here. This is a bow compass. This is what we've been using to draw circles, or at least what I've been using to draw circles. And this is what is called a straight edge. Now, I know this one has measurements on it. That's basically a ruler. But if you have a straight edge with no measurements, then you have a really true straight edge. Euclid wanted you to use a compass and a straight edge to make all of his figures. And he didn't like it when you came in with a protractor. If you came in with a protractor, he kicked you out. So it's very important that as you do Euclid's Elements, you use nothing but a straight edge. Oh, a straight edge. This is a straight edge here. And a bow compass. This is a bow compass. This is a straight edge. Make sure your straight edge has no numbers on it. Or if it does, just ignore those numbers. Because, believe me, Euclid would throw you out if you had numbers on your straight edge. And so that's what we're telling you here. Don't do that. Alright? Bow compass, straight edge. Alright, I will talk about more mathematical terms and computer terms in a future video, so stay tuned.